Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
Imagine a faint glimmer rising above the desert plain where silence stretches like a deep, velvety cloak. Under a sky washed in soft indigo, a humble instrument stands alone, a telescope with a slender tube and a glass eye. It reaches toward the heavens as if longing for a secret embrace, inviting us to peer beyond the veil of night. In the gentle hush, each breath seems to carry the promise of discovery. Light, traveling without sound across endless distance, drifts into the telescope like a quiet stream slipping through an open window. Within that glass chamber, we hold the power to gather whispers from worlds unseen. Even as our eyelids grow heavy, the telescope stays awake, a watchful friend guiding our wonder into the vast unknown. Before telescopes existed, we squinted at stars pinpricked in the night, each one a distant fire we could only imagine. The ancients told tales of gods and legends shaped by these tiny lights. But when a simple lens was shaped carefully by patient hands, everything changed. The lens bent the path of light, gathering it into a focused beam. It was as though someone had opened a secret door in the sky. Through that door, planets revealed their wandering paths. Rings around distant worlds shimmered like golden bangles. Moons danced around giants in silent orbits. Nebulas unfurled like cosmic flowers coloring the darkness. All these marvels drifted from the edge of sight into the welcoming eye of the telescope. Each glance became a voyage, a soft journey through space and time. In that gentle exploration, math and wonder walked hand in hand, guiding scientists closer to truths both profound and humbling. Crafting the first telescopes was an art of wood, brass, and polished glass. Fingers guided by steady hands shaped each lens, smoothing its surface until light passed through without a single ripple. The tube's walls were lined with dark velvet to hush stray glimmers, ensuring only the truest rays reached the eye. A mirror might sit at the base, tilted just enough to catch slanted beams and send them upward into our waiting gaze. Every adjustment felt like tuning a musical instrument, seeking the perfect harmony between focus and clarity. At night, builders would carry these instruments outside, aligning them with patient precision, until the first star cut a clear, bright path into the lens. Then came the quiet triumph of seeing Jupiter's bands or the rings of Saturn, hidden marvels finally revealed by the gentle craft of human hands. When Galileo lifted his simple spyglass toward the sky in 1609, he opened a new chapter in our cosmic story. He turned the telescope first toward the moon, tracing its craters and valleys with astonished eyes. What had once been a smooth silver ball now bore a rugged, mountain-carved face. Then he found companions wandering Jupiter's orbit, four little points of light dancing around their giant parent. Each night, he watched as they shifted positions, proof of a universe in motion. In soft Latin notes, he recorded his wonder, unaware that centuries later we would still feel that same thrill. His humble brass tube cracked open possibilities, whispering that our place in the cosmos was both smaller and more wondrous than ever imagined. Beyond visible light, telescopes listened to other melodies. Radio dishes capture distant murmurs from pulsars and quasars, translating waves that take millions of years to reach us. They stand wide and silent in fields, giant ears turned skyward, collecting whispers we cannot otherwise hear. When a supernova's shockwave sings in radio frequencies, we feel the echo of a star's final breath. Infrared telescopes peer through clouds of cosmic dust, unveiling nurseries where new stars sleep beneath blankets of gas. Each instrument stretches our senses, weaving the invisible into a tapestry we can explore. Through these gentle extensions of our eyes, the cosmos confides its secrets in ways both ancient and new. As light travels across space, it becomes a time capsule. When we observe the Andromeda galaxy, we see it not as it is now, but as it was 2 million years ago, before our distant ancestors stood upright beneath African skies. Every beam that enters a telescope carries stories of birth, life, and change. The farther we look, the older the light, the deeper our journey back through time. A single photon might have threaded its way through expanding space, grazing a black hole's edge or passing between unseen worlds, before resting in our lens. In the stillness of night, each point of light feels alive with history, as if the universe itself were telling us tales in whispers of color and glow. Modern telescopes drift above Earth in silent orbits. The Hubble Space Telescope floats in darkness, far above the haze of our atmosphere. It captures images of galaxies like painted spirals, distant clusters shining in soft pastel hues. Without earthly turbulence, its mirrors catch unbroken rays, revealing details that once hid in blur. When it trained its eye on Orion's pillars, colossal columns of gas stood backlit by newborn stars, glowing with gentle warmth. Each photograph seems to hum with silent poetry, inviting us to trace every curve and shadow. From its calm perch, Hubble reminds us that beauty and knowledge often arrive together in a soft unfolding of light. Back on Earth, giant observatories perch on mountain peaks, where air thins and light pollution fades. Under these vaulted skis, engineers adjust mirrors 12 meters wide, bending them thousands of times per second to cancel out shimmering air. The stars appear to hold still in their places, a celestial dance paused for our quiet reflection. In these remote places, a single voice can travel across the control room without raising its tone. The wind whispers outside like a soft chorus, harmonizing with the hum of cooling systems and the gentle click of shutters. Each night, astronomers slip inside domes of metal, opening shutters to touch the universe with their instruments and their dreams. In the deepest jungles and dry deserts, radio arrays spread like strange gardens of steel. Hundreds of dishes stand in careful formation, listening for the faintest signals. When they capture patterns from hydrogen atoms swirling in distant galaxies, they sketch maps of cosmic structure. In their gentle clicks and data streams, they speak of vast filaments stretching across the void, connecting clusters of galaxies like pearls on invisible threads. Scientists sit before glowing screens, weaving together these fragments of sound into pictures of shape and motion. It is a kind of music, quiet, low, and insistent, reminding us that even in emptiness there is a song. Each new telescope invites fresh wonder. The James Webb Space Telescope, with its golden mirrors folded like petals, will peer into the universe's earliest dawn. It will search for the first glimmers of light, when stars ignited like soft sparks in a darkened room. Infrared rays will slip through ancient veils of dust, painting pictures of infant galaxies awakening. Soon, we will hold these images in our hands, marveling at worlds born long before Earth existed. And as we gaze, we will remember that our curiosity has carried us across oceans, deserts, and the silent expanse of space itself. In the hush of the night, the telescope has become a bridge between us and the unknown. It teaches us patience, for each alignment and focus must be exact. It teaches us humility, for the universe holds more mysteries than we can ever grasp. Yet it also teaches us hope, as every new discovery promises another marvel just beyond our reach. When we peer through the eyepiece, we are joined with countless others across time, ancient stargazers, eager students, and modern explorers, each one lifting their gaze to the same shimmering canvas. Let your eyes rest now on that gentle instrument. Feel its cool metal under your fingers and its weight of promise in your hands. Listen for the soft sigh of distant worlds carried on light. In the calm, you become part of a gathering story, a story of small lives reaching toward infinite skies, of lenses that listen when words grow quiet, of hope and wonder held in a beam of starlight. Let's drift deeper now into the heart of the telescope, not just the brass or the mirror, but the quiet intention behind it. What makes us gaze upward in the first place? Perhaps it's the way the stars flicker like embers in a distant fire, or how the night sky wraps around us like a quiet thought too big to hold. The telescope doesn't just collect light, It collects longing. It gathers every question we've ever whispered into the dark. Where did we come from? Are we alone? What lies beyond the edge of sight? With every quiet adjustment of its lens, the telescope becomes an extension of our yearning, an eye not just for seeing, but for dreaming across space and time. The stars are not scattered randomly. They belong to neighborhoods, families, and clusters, and the telescope helps us trace these hidden bonds. Some stars burn hot and bright, fading quickly in cosmic terms. Others burn cooler, longer, softer, like red dwarfs, living billions of years in gentle glow. In the swirling arms of spiral galaxies, these stars gather like seeds drifting in invisible currents. And in the telescope's field of view, we begin to see the soft organization of the universe, a rhythm as quiet and certain as the tide. The telescope reveals that the cosmos is not chaos, it is structure, it is pattern, it is story unfolding in slow motion. Between the stars lie clouds, vast stretches of gas and dust, dark to the eye but glowing softly in infrared. These are the cradles of new stars, and telescopes allow us to peek inside their hush. In those cold nurseries, gravity gently pulls particles closer and closer until a core is born. The heat builds until hydrogen begins to fuse, and suddenly a new sun begins to shine. We cannot hear this birth, but we can see its warmth spill outward in soft pulses. Through our lens, we witness a silent celebration in the dark, new light joining the ancient chorus. It is a reminder that the universe is still becoming, still growing, still dreaming forward. Light is not instant, it travels, and that travel becomes a kind of memory, one etched across time and space. When we look at galaxies billions of light years away, we're not seeing them as they are, we're seeing them as they once were, long before our planet even formed. It is like looking at a photograph from a time we cannot visit, yet feel deeply connected to. The telescope becomes a time machine, not through fantasy but through the steady truth of physics. Every photon that reaches our lens is a survivor of a long journey, untouched, unchanged, bearing the delicate fingerprint of its origin. In this way, every observation becomes a kind of listening, a pause in the present to hear the echo of beginnings. In ancient cultures, the stars were maps, calendars, and songs. They were woven into stories passed from voice to voice, generation to generation. Now, through telescopes, we see that those ancient storytellers were right in a way. The stars do speak. Their colors tell us about their temperature, their spectra tell us about their composition, and their wobbles whisper of unseen planets pulling on them with gentle tugs. The telescope translates these messages into data we can hold, into images we can frame, into questions we can ask. Science, in its quietest form, is just another way of listening with care. Consider the galaxies, those massive swirls of stars and dust. Some are spirals with elegant arms that sweep outward like dancers. Others are ellipticals, round and soft like ancient lanterns. And some are irregular as if caught in a moment of transformation. Telescopes show us these grand forms, each one glowing with billions of stars. But they also show us how galaxies move, collide, and merge. Slowly, over eons, they fold into one another, spinning out streams of stars in luminous bridges. These aren't violent events but cosmic ballets, long, slow dances guided by gravity's invisible hand. It is beauty on a scale so large it humbles the breath, and yet, through our lenses, we get to witness it as gently as watching a cloud drift past the moon. Darkness itself holds mysteries. Telescopes don't just show us the glowing things, they reveal the shapes carved by the things we cannot see. Dark matter, for example, exerts a gravitational pull but emits no light. We see its influence in the way galaxies spin too fast, in the way clusters bend the light of distant objects behind them. This bending is called gravitational lensing, and it turns entire galaxies into soft magnifying glasses, curving space like the surface of a quiet pond touched by wind. Through the telescope, we glimpse these distortions and begin to understand that even the invisible can shape the universe. It is a tender reminder that not all truths shine, but they are real just the same. And what of exoplanets, those distant worlds circling other stars? The telescope gives us hints of them, not as clear images but as soft changes in light. A star dims slightly when a planet crosses in front of it. It wobbles faintly under the planet's pull. These tiny effects whisper of other places, places with clouds, oceans, perhaps even life. Some planets are scorching hot, others icy and pale. Some might be rocky and green, wrapped in atmospheres we can only imagine. Each new detection is like opening a letter from the cosmos, written in the delicate language of photons and gravity. These letters say, "You are not alone in your wondering." Our own moon, so familiar, becomes new again through the telescope. Its craters deepen, its plains stretch farther, shadows crawl along its edges as days pass. Each night reveals a different face, a new mood. The telescope teaches us to see not just far away but closer too. It reminds us that even the nearest things hold wonder when we pause to look. Saturn's rings, Jupiter's storm, Venus's phases, all unfold in slow, patient detail. The telescope slows us down, invites us to linger, to appreciate not just what we see, but how we see it. Even clouds on Earth affect what we observe. That's why space telescopes matter so much. They rise above our atmosphere's blur and shimmer. But Earth-based telescopes adapt too. Some use lasers to create artificial stars, measuring how the atmosphere distorts the light and correcting it in real time. This process, called adaptive optics, is like calming ripples in a pond to reveal the stones below. It is a quiet triumph of technology and tenderness, of learning to see clearly despite the shifting winds above us. Then there are gravitational wave detectors, telescopes of a different kind. They do not use light but feel for tiny ripples in spacetime caused by cataclysmic events like black hole mergers. When those waves pass through Earth, they stretch and squeeze everything by amounts smaller than a proton. And yet we can detect them. In long, quiet tunnels lined with lasers and mirrors, we listen not with eyes but with the fabric of space itself. These detectors are like fingers pressed lightly against the universe's wrist, feeling for a pulse. They remind us that even silence holds rhythm. The stories that telescopes tell us are not always complete. There are gaps, questions, puzzles unsolved. But that's part of the beauty. They leave space for wonder. Each image taken is both an answer and an invitation. The telescope doesn't speak loudly, it whispers. And in listening, we become gentler, more patient, more curious. Science done through telescopes is not only discovery, it is communion. A slow, steady reaching across light years to understand the nature of being. As night deepens and the stars come out one by one, remember this. Every telescope, no matter how small, opens a doorway. A child with a paper tube can begin a journey. An amateur with a backyard scope can spot the moons of Jupiter. And a great observatory can chart galaxies dancing on the edge of time. Each one plays its part. Each one reminds us that seeing is more than vision, it is connection. A telescope gathers light, yes, but more than that, it gathers us. Our hopes, our questions, our quiet, star-shaped thoughts. It holds them gently, then reflects them back in soft starlight. Now let us follow the light even farther to the quiet edge where the universe fades into its own beginning. Telescopes, those still companions of the night, reach deeper with each generation, seeking not only stars and galaxies but time itself. The earliest light, soft as candle glow across endless black, began when the universe was still young and unshaped. It shimmered forth when matter cooled, when atoms found each other, when the first hydrogen gas let light escape into open space. This light, called the cosmic microwave background, drifts across the universe like a lullaby of origin. And the telescopes that capture it, quiet instruments cradled in high balloons, frozen deserts, or orbit, record its faint temperature ripples. These ripples hold the shape of the infant universe, swirled and stretched like the folds of a sleeping child's blanket. From those gentle patterns, we trace the earliest motions, the earliest whispers, the very breath of what would become stars, galaxies, and us. Yet even as telescopes reveal beginnings, they also show us endings. Stars live beautiful lives, but they too must rest. When a massive star has spent its fuel, It collapses inward and then explodes outward in a supernova, a blossom of energy brighter than a galaxy, glowing for only days or weeks. Telescopes capture these cosmic farewells in real time. The light, having traveled for millions of years, arrives at just the moment we are watching, like a message perfectly timed. And as we observe, we see more than fire. We see the creation of gold and silver, of iron and calcium, the very elements that now sit in our bones and flow through our blood. Telescopes show us that even in the death of stars, there is giving, there is making, there is quiet legacy. Sometimes the telescope points at what isn't there. A patch of sky where nothing seemed to shine becomes, with long exposure, a window to thousands of galaxies. This happened with the Hubble Deep Field, a small dot of sky barely the size of a grain of sand held at arm's length. Astronomers stared into it for days, and slowly galaxies began to appear. Not one, not 10, but thousands, each with stars, each with possibilities. These galaxies, older than our sun, had been waiting all along. It was only our attention, our patient gaze, that made them visible. And so, the telescope becomes not just a finder of things, but a teacher of attention. It tells us that the world is fuller when we look deeply and wait quietly. That silence, time, and focus reveal abundance. Telescopes do not work alone. They are part of networks like voices in a choir. Radio arrays link across continents, forming virtual dishes the size of Earth. These telescopes together captured the first image of a black hole's shadow, a round, soft blur surrounded by a halo of light. That black hole in the heart of a distant galaxy does not shine. It only bends light around it, warping space like a dream curled in on itself. And yet, because of careful coordination, because of trust between scientists, because of the still patience of waiting dishes, we saw the unseeable. The telescope, in this way, becomes an act of human unity, a tool of curiosity shared by many hands and many hearts. There are telescopes yet to come, still in pieces, still in plans. The extremely large telescope in Chile will have a mirror the size of a basketball court. It will peer at exoplanet atmospheres, looking for molecules like oxygen and methane, signs perhaps of breathing life. The Nancy Grace Roman Space Telescope will scan wide fields, catching the dim drift of galaxies across time. These instruments are not just machines, they are promises. Promises to keep watching, to keep wondering, to never turn away from the quiet call of the stars. Their construction is delicate and determined. Their purpose is both precise and poetic. They are the next notes in a long lullaby of looking. But even the smallest telescope can be enough. In a city balcony, a child can lift a telescope to the sky and see Saturn's rings for the first time. The image may shimmer, may dance in the heat of the atmosphere, but the wonder will be clear. That Saturn, that tiny circle in the sky, has structure, has moons, has storms. That same child may return the next night and the next, learning the sky not through textbooks but through time. The telescope, then, is not just a science tool, it is a doorway. It opens not just the heavens but the heart. It teaches us patience, awe, and the rhythm of returning. In dreams, we often fly. We rise above rooftops, above clouds, into the stars. The telescope lets us do this while waking. It lifts our gaze beyond what is near, beyond what is daily. It places us in perspective, not smaller, not insignificant, but woven into the grandness. When we see a galaxy millions of light years away, we do not feel lost, we feel found. Because something in us matches that spiral, that motion, that glow. The telescope reflects not just light, but our own longing. To be part of something vast, to know, to belong, to marvel. And still there is more. Telescopes also show us Earth. Some face downward, capturing oceans, forests, clouds. They remind us that our world, too, is a planet spinning, breathing, blue and bright. And when telescopes leave Earth behind, they carry pieces of us, names, hopes, tiny disks etched with music and math. We send telescopes into deep space not only to find others, but to let others find us. In the quiet vacuum, these messengers float, open-eyed and listening. They are like paper lanterns set adrift, carrying gentle signals of life. As we near the close of this story, picture a mountain at night. On its summit stands a dome, silver under stars. The dome opens and the telescope tilts upward. Inside, someone leans forward, breath held. The stars slide into view. The universe becomes a little more detailed, a little more personal. That person is not alone. Around the world and through time, others have looked too, through glass, through mirror, through code. The act of watching connects us. The telescope connects us. Now the stars are fading and morning comes. The telescope will rest, its dome closing with a soft sigh, but the light it caught will stay. In data, in memory, in dreams, for we are the keepers of starlight now. We carry it in our eyes, in our questions, in our quiet readiness to look again. The telescope is not just a tool. It is a way of seeing, a way of being gentle with mystery, a way of saying, I am listening, I am watching, I am here. High above the clouds, where the air thins and time seems to slow, a mirror waits in silence. It does not reflect the face of the one who peers into it, but something deeper, something older, a reflection of stars born before Earth cooled, of galaxies drifting across dark oceans of space. This is not a mirror of vanity, but a vision, polished not for beauty, but for clarity. It sits hidden inside the body of a telescope, curved with such precision that it can catch the softest beam of starlight and hold it gently, without breaking it. These whispering mirrors are the quiet hearts of modern astronomy. With them, we listen not to sound, but to light, light that has traveled alone across billions of years to arrive in our waiting eyes. A mirror curved just so can do something magical. When light from a distant object strikes it, that mirror can gather the light's faint threads and pull them together. It can guide scattered photons inward, bending their paths toward a single point of focus. This is how telescopes see clearly, even across the vastness of space. At the heart of a reflecting telescope lies this mirror, often called the primary. It might span a meter or 10 or even more, depending on the ambition of the gaze. It must be polished to a tolerance smaller than the width of a single human hair. Even the tiniest flaw can blur a galaxy. And so, with tools and patience, with cloth and polish, engineers create surfaces so smooth they seem more idea than object. These mirrors whisper back only what the universe gives them, nothing more, nothing less. Long ago, the first telescopes used lenses alone. But as scientists reached for fainter stars and farther planets, they turned to mirrors. In the 17th century, Isaac Newton built a small telescope with a curved metal mirror, avoiding the problem of color distortion that lenses often caused. His simple device revealed craters on the moons of Jupiter, the phases of Venus, all with clarity and grace. And from this gentle beginning, mirrors grew larger, stronger, more precise. In the great domes of observatories, metal turned to glass, and glass became silvered with thin layers of aluminum or gold, allowing even dim starlight to leave an impression. Today, we owe our clearest cosmic views to these whispering mirrors and the quiet science they reflect. There is poetry in how these mirrors are made. Imagine a giant disk of glass, thick and heavy, resting on a spinning table. It turns slowly at first, then faster, and the molten surface rises along the edges like water swirling in a bowl. As it cools, it takes the shape of a parabola, perfect for focusing light. Then comes the polishing, the testing, the endless refining. Lasers scan the surface, measuring imperfections so small they defy the senses. For months, sometimes years, the mirror is smoothed and checked again. Technicians work not in haste, but in harmony, knowing that one soft blemish could hide a star. They work in quiet rooms, away from vibrations, sometimes in darkness, as though listening for the shape of light itself. When light finally strikes the finished mirror, it bounces cleanly, curving inward. A second mirror, smaller and angled, redirects that beam toward a detector or an eyepiece. The path is elegant, a choreography of reflection and focus. And along that path travels a story of the object that sent the light, of the journey it took, of the moment we receive it. Through the mirror, we do not just see the object. We see its past. We see its changes. We see how it fits within the wide and quiet architecture of space. With mirrors, we glimpse the structure of things far beyond our reach. And in that glimpse, we feel closer. Some mirrors are made not as single pieces, but as mosaics, hexagonal segments fitted like honeycomb. This is how the James Webb Space Telescope was built, its golden panels unfolding in space like petals opening to the stars. Each segment can tilt and bend, aligning with the others to form a flawless eye. This ability to adjust, to adapt, makes the telescope not just strong but sensitive. It can find galaxies behind veils of dust, and light so old it arrives as faint warmth. These segmented mirrors are not rigid. They breathe, respond, shift to stay focused even as their target moves. It is as if the mirror listens, leans in, offers a quiet yes to the universe's faintest signals. In radio telescopes, the mirrors take a different form, vast dishes, sometimes hundreds of meters across, catching radio waves from deep space. These mirrors are not smooth but finely meshed like spiderwebs of steel. They don't need polish because radio waves are long and forgiving. What matters is shape and direction and silence. These great bowls turn slowly, almost lazily, across the sky. They wait and they listen. When pulsars blink or galaxies hum in low frequencies, the radio mirrors catch their voices. These telescopes don't see exactly. They hear, and in their stillness they reveal symphonies no human ear could detect. Some mirrors are designed to move, to change their shape in real time. These adaptive optic systems use computer-controlled pistons to flex the mirror's surface hundreds of times per second. Why? Because Earth's atmosphere wobbles and ripples, making stars twinkle but blurring the view. Adaptive mirrors fight this distortion, adjusting faster than the eye can see, sharpening each image with every breath of the wind. It's a dance of feedback and focus, of constant correction. And in that delicate ballet, the telescope sees as if floating in space, crisp, detailed, true. The whispering mirror becomes not just passive but alive. In the future, mirrors may float freely in space, separated from their detectors by thousands of kilometers. These space-based interferometers will use the difference in arrival times of light to build images finer than any single telescope could manage. It's a kind of cosmic origami, folding light with math and mirrors to create detail far beyond what our eyes alone can manage. In this vision, mirrors become parts of constellations, working together across the vacuum to draw the cosmos in exquisite detail. Each part listens. Each part reflects. Together, they whisper truths too fine to hear alone. These whispering mirrors don't judge what they reflect. They treat the faintest galaxy and the nearest moon with equal care. They shine back the universe as it is, gentle, wild, strange, and full. They do not amplify, they do not distort. They simply offer back the light that comes to them, quiet and true. And in doing so, they teach us a way of seeing that is humble and whole, to listen without shouting, to look without claiming, to reflect without holding. That is the gift of the telescope's mirror. That is its soft, endless song. Let's wander further now, deeper into the long corridors of starlight that these whispering mirrors reveal. At night, beneath a velvet dome scattered with stars, we often forget how little of the universe we truly see with our eyes. But when light touches the surface of a mirror, when it curves inward and finds focus, it carries with it the quiet fingerprints of creation. Every reflection is a clue, a soft confession from some faraway sun or spinning galaxy. And in those clues, scientists have found the rhythm of the cosmos. The mirrors, silent and still, let us read the temperature of stars, the age of galaxies, the chemical recipe of distant planets, all from the safety of Earth, with our feet firmly on the ground and our minds stretched across the void. When astronomers study the light gathered by these mirrors, they often pass it through prisms or diffraction gratings, breaking it into rainbows called spectra. Each spectrum is a painting of light's journey, a silent biography of its source. In the dark bands and bright lines, scientists see hydrogen, helium, oxygen, carbon, the building blocks of stars, of planets, of life itself. These lines reveal motion too. A star moving away stretches its light, shifting it toward red. A star moving closer pulls its light into blue. This redshift and blueshift, gentle as breath, lets us measure the dance of galaxies. And in those shifting hues, the mirrors whisper of expansion, of gravity, of space stretching like soft fabric. Through this simple bending of light, We find the fingerprints of the cosmos and the quiet rhythm of its ongoing change. One of the most delicate things mirrors have shown us is how the universe is not static. It's growing, expanding, unfolding. The light from distant galaxies doesn't just arrive. It arrives stretched, worn thinner by the growing space between stars. This discovery, first seen through telescopes in the early 20th century, changed everything. It meant that the universe had a beginning, that all galaxies once huddled close in an unimaginable burst of light and heat. Mirrors don't just reflect stars, they reflect ideas, transformations, truths. They help us understand not only what is, but what was and what might still become. They are tools for seeing across time, catching the flow of the universe in silent, shining streams. Let's pause here by a great observatory built into a mountaintop. The night air is thin, cool, and quiet. The dome opens with a slow hum, and the telescope begins to turn, its movements graceful, deliberate. The mirror inside, polished and waiting, tilts gently toward a patch of sky filled with galaxies. To the human eye, that patch looks almost empty. But as the exposure begins, as the mirror gathers light over minutes and hours, the image blooms. Distant spirals, soft glows, arcs of ancient light emerge from the dark. It's like watching a pond slowly clear after the ripples have faded. The universe reveals itself not in flashes but in patience. And the mirror, motionless and steady, becomes a bridge between absence and understanding. Some mirrors do their work from space, floating above Earth's atmosphere. They're free from clouds and turbulence, they see more clearly, more deeply. The Hubble Space Telescope, with its golden mirror and quiet orbit, has captured images so delicate they look like dreams. Pillars of gas where stars are born, dusty spirals where gravity weaves new worlds, clusters of galaxies glowing like lanterns in the dark. Each photograph is a reflection not only of the sky, but of our hunger to know it. Hubble's mirror, though small compared to newer designs, is polished to such precision that it can detect changes in light too faint for any human sense. It watches constantly, gently, faithfully. And now, the James Webb Space Telescope joins this celestial vigil, its mirrors bathed in gold and folded like wings. Deployed far beyond the moon, cooled until it is nearly as cold as space itself, it listens for the softest whispers of heat, the oldest echoes of light. Where Hubble saw the visible and ultraviolet, Webb sees the infrared, the warmth left behind from stars long gone. In this light, hidden galaxies emerge. Stars wrapped in dust become visible. Planets orbiting distant suns begin to show their secrets. The mirror, curved with care and steadied by silence, gives us access to the beginning of time. We see not just stars being born, but the very moment light found freedom. Closer to home, whispering mirrors help us find planets beyond our solar system. They don't always show us the planets directly, but they detect their presence through shadows and wobbles. A planet passing in front of a star dims its light slightly, rhythmically. A star pulled gently by a planet's gravity shifts in its color. These are small signs, barely a breath, but mirrors catch them. From these quiet clues, we've found thousands of exoplanets, some rocky, some gaseous, some wrapped in atmospheres we can now begin to study. We've learned that planets are not rare, they're common, that stars often carry worlds, that the quiet song of a mirror can reveal the possibility of life. Whispering mirrors have also led us to black holes, not because black holes shine, but because they bend light around them. In galaxies, stars move in odd orbits, spinning too fast for what we can see. Only by accounting for invisible mass, black holes at the center, do the equations balance. And then came the shadow. Using mirrors linked across the globe, scientists formed a virtual Earth-sized telescope. In 2019, they imaged the shadow of a black hole, a dark circle framed by swirling light. It was not a photograph in the usual sense, but a reflection of math, of motion, of gravity's quiet hunger. The mirror helped us see the invisible, and in doing so, it reminded us that some truths can only be found by looking softly, patiently together. In Antarctica, mirrors face upward through dry, frozen air, catching light undisturbed by moisture. In Hawaii, on Mauna Kea's summit, telescopes rise above much of the world's atmosphere. In Chile's Atacama Desert, under the clearest skies on Earth, mirrors turn night after night, gathering data. Each site chosen not for comfort but for clarity. Each mirror built not for ease but for vision. And every one of them, whether massive or modest, shares a common gift. They let us see what we cannot otherwise see. They gather the unseeable into form. Even on Earth, mirrors teach us about our own star, the Sun. Specialized telescopes observe solar flares, sunspots, and the solar wind. These mirrors are shielded, filtered, designed to handle intense light. They help us understand the heartbeat of our star, how its rhythms affect Earth, how its cycles shape climate and communication. Through them, we see that our own sky is not static. It pulses with energy, with heat, with beauty. And as all these mirrors look outward, they also bring us inward. They help us ask, what does it mean to see? What does it mean to reflect? What do we learn not just about the stars, but about ourselves when we build such instruments of wonder? Perhaps the answer lies not in any single observation, but in the act itself, in the choice to look, in the care with which we build, polish, point, and wait. The mirror does not hurry. It does not force. It opens, receives, reflects. And in doing so, it shows us a gentler way to seek truth. Now imagine the telescope resting beneath a sky scattered with stars, its mirror turned upward like an open hand. It waits not for anything in particular, but for whatever the universe chooses to give. This is the quiet devotion of astronomy, the willingness to look without promise, to reflect without expectation. In this final stretch of our journey, let us sit beside that mirror and consider the meaning of its work. Not only the images it gathers, but the feelings it stirs: wonder, humility. A kind of stillness that lives within the act of deep observation. The mirror, after all, is more than a tool. It is a way of being, a way of listening to the cosmos with gentle eyes. The mirror shows us change. We see stars in all phases of life, being born from clouds of dust, burning with steady light, swelling into giants, then fatting into ashes. Each star, each glowing dot, holds a history older than humanity. Some live short, brilliant lives, others glow for billions of years. When we look at these stars through a telescope's mirror, we are looking at their past, not their present. The light has taken time to travel, sometimes centuries, sometimes eons. We are always witnessing a moment already gone, and yet it feels alive. It feels like conversation. The mirror gives us this strange paradox: presence through absence, the now hidden inside the ancient. When we observe distant galaxies, we also observe distance itself. The mirror teaches us that space is not empty. It is stretched, curved, alive with structure. There are filaments of galaxies, clusters like cities in the night, and vast voids where almost nothing shines. This structure did not form randomly. Gravity, time, dark matter, all work together to shape the cosmos into this breathtaking architecture. And when we reflect this structure back through our mirrors, we begin to understand how even in the deepest stillness, there is movement, there is form. We are part of that form. The dust that built stars also built us. The mirror does not exaggerate this truth. It simply offers it back, clearly and kindly. Sometimes the mirror catches light from a dying star, perhaps a supernova that exploded long ago. In that flash, heavier elements were born. Iron, calcium, carbon. These are the ingredients of planets, of oceans, of our very bodies. When the mirror reflects such a scene, it shows us not only destruction, but creation. The ashes of stars become the seeds of worlds. In this way, the mirror tells a story of recycling on the grandest scale. And in that story, we are not observers, we are participants. We carry the memory of stars in our bones. We are stardust, made aware of itself, looking back into the sky from which it came. Whispering mirrors have also revealed the unexpected. Sometimes, a telescope finds a quasar, a brilliant point of light that outshines its entire galaxy. These are powered by black holes feeding on matter, releasing energy as they spin. Or a telescope might glimpse gravitational lensing, an object bending light around it, creating arcs and rings that look like illusions but are real, measurable phenomena. These moments remind us that the universe is full of surprise, full of nuance, full of phenomena that stretch our imagination. And the mirror, unshaken, continues to reflect them all with steady calm. Think now of the mirrors we have launched into deep space, beyond Earth's orbit, beyond the moon, where no hands can adjust or polish them. These mirrors must work perfectly, sometimes for decades, without repair. And yet they do. They unfold in silence, track stars with precision, and beam their findings back across millions of kilometers. It is a triumph not only of engineering but of trust. We trust the mirror to hold its shape. We trust it to keep its promise. And so far it always has. Even in the cold, in the dark, in the vast quiet, it does its work without complaint. Back on Earth, students peer through small telescopes at local observatories. They adjust focus rings, nudge tripods, wait for clouds to pass. When the sky clears and the mirror catches starlight, there is a moment, quiet, breath held, when everything changes. A ring around Saturn becomes real. A crater on the moon sharpens. A distant nebula glows faintly. That mirror, no larger than a dinner plate, reflects more than light. It reflects the beginning of a lifelong curiosity. A mirror does not need to be large to awaken wonder. It only needs to be open, still, and pointed in the right direction. Some mirrors are even carried on spacecraft, sweeping past planets. The mirror on Voyager captured the famous pale blue dot image Earth as a speck in a sunbeam. That reflection, soft and haunting, reminded us of our fragility, our unity, our smallness within the grand design. Carl Sagan spoke of that image with reverence, calling Earth a mote of dust suspended in a sunbeam. The mirror gave us that vision, not through drama but through presence. A steady eye turned back home for just a moment, capturing a truth too vast for words. In the coming years, we will send more mirrors skyward. Some will look for biosignatures, hints of life on distant exoplanets. Others will study dark energy, that mysterious force pushing the universe apart. Some will be balloon-borne, others cooled to near absolute zero, others orbiting at Lagrange points. They will operate silently, tirelessly, and they will reflect not only stars, but our deepening desire to understand. Their images will flow to Earth like gentle messages, awaiting interpretation. And always there will be someone, some child, some scientist, some poet, ready to receive them. So now in this final quiet, picture yourself beside a mirror in the dark. No noise, no rush, just the soft hum of equipment, the slow drift of stars overhead. You lean close not to see your own reflection, but to see the past, the possible, the infinite. You become part of the light's journey, from a star's surface to a telescope's mirror to the back of your eye. That path, so long in distance, becomes intimate in meaning. The mirror does not speak, but you hear it. It does not move, but you feel it. It does not breathe, but it reflects life in its widest, deepest form. The universe is full of light, and we are its listeners. The mirror simply helps us hear better. Its gift is quiet but complete. In its stillness, we are made more awake. In its silence, we are taught to listen. And through its gaze, we find our place, not apart from the stars, but among them. Not looking in from the outside, but looking outward from within. Far across the stretch of sky where the stars begin to blur into memory, galaxies drift in quiet procession. They do not roar or flicker loudly. They do not rush. They move slowly, like ancient ships sailing across a sea of time. These galaxies are so distant that their light has taken billions of years to reach us, and by the time it enters the lens of a telescope, it has grown soft and stretched, turned red with age. Each faint glimmer is not just a point of light. It is a voice, a story told in silence, waiting patiently to be heard. The telescope, with its gentle touch and whispering mirrors, catches these ancient voices and brings them close, translating their light into shape, color, motion, and meaning. In the hush of night, when all else has gone quiet, we listen. And in that listening, we begin to understand. Galaxies are more than collections of stars. They are ecosystems, communities evolving over billions of years. They carry within them the traces of birth and destruction, of gravity's subtle architecture. Each galaxy is made of stars, some young and blue, burning hot and fast, others old and red, glowing with quiet wisdom. But beyond the stars are rivers of gas, tides of dust, clouds of molecules weaving between systems like silent winds. And deeper still is dark matter, a presence we cannot see but can feel, a gravity that binds the galaxy together like a ghostly web. All of these parts move in concert, turning slowly, spiraling through space, never quite repeating the same step twice. From afar, they seem still, but up close, through the eye of a telescope, they shimmer with life. The light from these galaxies tells us what they're made of. When passed through a spectrograph, it reveals fingerprints, lines of hydrogen, oxygen, calcium, and iron. Each element leaves its mark in the starlight, like ink in invisible inked letters, waiting to be read. From these patterns, astronomers can tell how hot the stars are, how old the galaxy is, and how fast it's moving. Some galaxies move away from us, their light shifted toward the red end of the spectrum. Others move slightly toward us, though most are caught in the gentle swell of cosmic expansion, drifting farther apart as space itself stretches. And so, in their silent light, we learn about time, distance, and the very shape of the universe. Not all galaxies are the same. Some spin like graceful spirals, their arms curved with dust and stars, glowing in waves of blue and white. These spiral galaxies are like pinwheels of light, forming new stars in their arms while older stars gather at their centers. Other galaxies are elliptical, soft ovals made of older stars, glowing red and gold. They are quieter, more settled, having spent much of their energy in earlier epochs. And then there are irregular galaxies, shaped like smudges or clouds, pulled and stretched by the gravity of nearby neighbors. Each one is unique, a fingerprint of cosmic history. And through telescopes, we can study their forms not just as static images, but as windows into how galaxies live and change. Some galaxies live alone, far from neighbors, evolving quietly. Others exist in crowded clusters, drawn together by dark matter and gravity, orbiting a common center like bees around a hive. In these dense clusters, galaxies interact. They pass close, tugging at each other's arms, stripping gas, stirring stars, sometimes even merging into one. These interactions are slow, lasting millions of years, but through careful observation, we see snapshots of them in various stages. Two galaxies about to touch. Two galaxies beginning to blend. One galaxy caught in the gravitational pull of another, its stars stretched like threads of light. These moments reveal not chaos but choreography, a cosmic ballet directed by gravity's steady hand. At the center of many galaxies, including our own Milky Way, lies a mystery, a supermassive black hole. These giants are millions or even billions of times the mass of our Sun. They pull in gas and stars, heating them until they shine in X-rays and radio waves. Sometimes they erupt, shooting jets of energy far into space. When this happens, the galaxy speaks not in light, but in force. The black hole's voice is invisible, but its effects shape entire regions of space. It can stop stars from forming or help them begin. And though it cannot be seen directly, we find its presence in the way stars near the center move, in the X-ray flares that pulse from invisible points. The telescope, tuned to many forms of light, captures these signs like echoes bouncing through stone halls. The oldest galaxies we know are seen as they were just a few 100 million years after the Big Bang. They are faint, red, barely distinguishable from the background. But with careful focus, with hours of exposure, they appear, tiny smudges of light that have traveled almost the full age of the universe to reach us. These are the ancestors of modern galaxies. Small, irregular, forming stars rapidly, filled with the raw materials of future complexity. In them we glimpse the beginning of structure, the first starlight piercing the cosmic dark. To see them is to look through time itself, to touch the edges of history's veil. Their light does not speak loudly, but it speaks truly, and through our instruments we have learned to listen. There is also light we cannot see: infrared, ultraviolet, radio, and X-ray. Different telescopes are tuned to these wavelengths, revealing galaxies in different ways. Infrared light shows us dust and warmth, often hiding newborn stars cradled in gas. Ultraviolet light highlights young, hot stars shining in fierce, short lives. X-rays show us violence, black holes colliding galaxies, the remnants of exploded stars. And radio waves show us the large-scale structure, the clouds of hydrogen gas stretching across vast distances. Each of these windows opens a different story. Each reveals a different voice. Together, they create a layered, textured understanding of galaxies as living, breathing systems. As our instruments improve, we continue to find galaxies farther away, older, fainter. With the James Webb Space Telescope, astronomers have already glimpsed galaxies forming earlier than we thought possible. These discoveries change our timelines, challenge our models, and inspire new questions. How fast did stars begin to form? How quickly did black holes grow? What kinds of matter shaped these early systems? And always, the galaxies answer with light. Thin, ancient, precious, collected one photon at a time by mirrors held still in the darkness. In the silence of space there is no sound, but through the quiet language of light galaxies sing. Their voices are slow and soft, yet full of meaning. The telescope acts like a translator, turning this ancient song into images, into data, into understanding. It brings us close to what was once unimaginably far. And in doing so, it brings us closer to ourselves, not just as watchers of the sky, but as part of the sky, shaped by the same forces, made of the same dust, lit by the same light. Let us drift even deeper now into the heart of these ancient galaxies, where stars form like raindrops falling in reverse, condensing not from clouds in the sky but from clouds in space, vast nebulae rich with hydrogen and dust. Within these clouds, gravity does its slow and silent work, drawing particles together until a new star is born in a quiet blaze of fusion. It is here, in these stellar nurseries, that galaxies renew themselves, over and over, reshaping the light they send into the universe. Some galaxies glow with youthful energy, their arms dotted with brilliant blue stars burning hot and fast. Others are quiet, more subdued, where star formation has slowed and the population of older, redder stars dominates the scene like the long, golden hour before dusk. The light from these stars travels outward, bouncing off dust, blending in waves, before finally reaching our instruments. Soft messages from another time, folded into photons and scattered across the sky. Galaxies also speak through their structure. A spiral galaxy with its delicate arms spinning outward reveals motion, both ordered and wild. Those arms are not rigid spirals but density waves, patterns of compression that pass through the galactic disk like ripples through a pond. As they move, they trigger the birth of new stars, lighting the arms like pearls on a string. The core of the galaxy, bright and crowded, holds older stars, orbiting in complex paths influenced by the hidden mass within. Beyond the arms, a halo of faint stars and ancient globular clusters quietly orbits, like memories trailing in the dark. All of this is held together by gravity, bound by forces we can calculate but still find mysterious. Dark matter, unseen but essential, makes up the majority of a galaxy's mass, creating scaffolding around which the visible parts are arranged. We do not see it, but we see what it does, and so we know it is there. In elliptical galaxies, where star formation has mostly ceased, the light is smooth, golden, and even. These galaxies are often older, formed from the mergers of smaller systems long ago. Their stars move in all directions, not just in neat circles, creating a soft hum of random motion. There are no bright spiral arms here, no hot young stars, only a sea of elders drifting quietly through the centuries. Yet even in these quiet galaxies, activity lingers. Some still host black holes at their centers. Some still carry thin trails of gas, relics of their past lives. And some may even harbor dormant potential, waiting for a spark, an interaction, a collision to awaken them again. Galaxies do not live in isolation. They are shaped by the company they keep. In clusters, galaxies interact through long, slow dances. As they pass close to one another, gravity pulls on their gas and stars, creating tails and bridges of matter stretching across space. Sometimes galaxies merge entirely. Two spiral galaxies may collide, their stars passing mostly untouched due to the vast distances between them, but their gas clouds smashing together, igniting bursts of star formation. The result can be a new kind of galaxy, larger, more complex, often elliptical in form. These mergers are not violent in the way we think of collisions, but they are transformative. They change the shape, the content, the destiny of each participant. And the light from such events, caught mid-motion, shows us that galaxies are not frozen. They are evolving, becoming, reshaping. In the space between galaxies lies something even more elusive, the intergalactic medium. This is the thin gas that stretches across vast distances, nearly invisible, yet carrying the remnants of ancient stars. Through careful measurements, astronomers detect this medium by the way it absorbs certain wavelengths of light from quasars far behind it. These shadows, called absorption lines, tell us about the chemical composition, temperature, and motion of this almost empty space. Even here the universe whispers. Even here there is story. The telescope's mirror does not discriminate between brightness and faintness. It gathers what it can, and through patience and care, we learn to hear the quietest voices. And then there are the galaxies so far away. Their light has been redshifted nearly into radio waves. These are the earliest galaxies, formed just a few 100 million years after the Big Bang. Their light has traveled for over 13 billion years to reach us. They appear not as grand spirals or elegant ovals, but as clumps, knots, flickers of light barely brighter than the background. They are raw, chaotic, star-forming machines, dense with energy and dust. Observing them is like looking at an infant's face in a darkened room, faint, shifting, but full of potential. With new infrared telescopes, we are beginning to see these galaxies in better detail, learning how the first large structures assembled in a cosmos still cooling from its birth. There is also the strange beauty of gravitational lensing, where massive clusters of galaxies bend the space around them and magnify the light from galaxies even farther away. These lenses create arcs, rings, and distorted images, like reflections in a warped mirror. Through these cosmic magnifying glasses, we see galaxies that would otherwise be invisible. Sometimes, the same galaxy appears more than once, its light taking different paths through curved space. This phenomenon, predicted by Einstein and confirmed through decades of observation, shows us that even space itself is shaped by mass. It's not only the galaxies that speak, it's the space around them, bending and guiding their light like a quiet hand. In studying galaxies, we also learn about our own. The Milky Way, seen from Earth as a glowing ribbon across the night sky, is a spiral galaxy with a bar of stars at its core. Our Sun is just one of hundreds of billions of stars orbiting within one of its arms. We cannot step outside to view our galaxy fully, but by comparing data, mapping star movements, and listening to the echoes of other galaxies, we have built a picture of our home. We know it turns slowly, that it has satellite galaxies of its own, that it will one day merge with the Andromeda Galaxy in a union so vast it defies imagination. Even this grand event will not be loud. It will be a quiet interweaving of stars and dark matter, a reshaping of light over billions of years. And through all of this, through structure and shape, through movement and change, the galaxies remain. They do not hurry, they do not explain themselves. They simply are, and in their being they offer knowledge. Every time we turn a telescope toward the sky, we add another brushstroke to the portrait of the universe. The galaxies respond, not with noise or urgency, but with the silent offering of their light. And it is in that offering, in that gentle presence across space and time, that we begin to understand our place within the grand unfolding of the cosmos. Let us now follow the light to its softest fatting, where the oldest galaxies begin to slip into silence. These ancient structures, barely visible against the black tapestry of space, continue their slow journeys through the expanding universe. Though their voices grow fainter with each passing eon, the telescope still listens. It listens not with ears, but with glass and sensors and mirrors shaped by patient hands. And what it hears is not sound, but time itself, carried by light stretched across distance, bent gently by gravity's curve. These galaxies, long past their youth, have become quiet guardians of cosmic history. They shine less brightly, but they shine with the depth of all they have seen. The births and deaths of stars, the mergers of neighbors, the cooling of gas, the long drift into stillness. Some of these galaxies are called red and dead, not because they are lifeless, but because their days of active star formation have ended. They glow with the dim light of old stars, stars that burn slower, cooler, longer. Their gas has been used up or stripped away, their dust settled into quiet corners, but within them lies a record of time more enduring than any monument. Their stars carry elemental fingerprints from every generation that came before, telling stories of nucleosynthesis, of collisions, of rebirths that now sleep. And in their gentle glow, the universe preserves its own memory, a fading light that reminds us of what was, even as it drifts farther from what is. As galaxies age, they are shaped not only by what they do, but by what they endure. Tidal interactions with neighbors pull at their arms, distort their shape, send waves through their disks. Supermassive black holes at their centers may flare into quasars, consuming matter and flinging energy outward. Sometimes, entire clusters of galaxies move together, bound by gravity, threading through space like braided rivers of light. These interactions leave marks. A galaxy's structure becomes a map of everything it has encountered, a tilted disk, a warped halo, a stream of stars drawn out into space. Telescopes allow us to trace these maps, reading the stories of long-ago interactions written in the language of light and form. And as we gather more data, we find patterns. Galaxies that formed earlier tend to be more compact, more intense. Those in dense environments evolve differently than those in the quiet solitude of empty space. The presence of dark matter and the pressure of surrounding gas shape their destinies in ways still only partly understood. Yet even in our uncertainty, we are filled with wonder. Because every galaxy we observe adds a thread to the grand tapestry, a single glowing knot in a vast, woven universe. And with each observation, the design becomes clearer. Not complete, perhaps, but more beautiful in its complexity. Now consider the silence that follows a galaxy's fading. It is not emptiness, it is rest. Just as a fire burns low and leaves behind warm embers, so too do galaxies carry on after their brightest days. Their stars continue to orbit. Their black holes continue to spin. Their gravitational fields still pull gently on the surrounding fabric of space. And though new stars no longer light their skis, the galaxies endure, timeless, patient, and steady. Through the telescope, we witness this endurance. We see not decay but maturity, not stillness but presence, a presence that asks for no attention but offers meaning nonetheless. There are galaxies we have only recently discovered, ultra-diffuse galaxies, so faint that they were invisible to earlier surveys. These ghosts of the cosmos float like whispers, barely denser than the surrounding darkness. Some are large but filled with very few stars. Others contain no dark matter at all, an anomaly that challenges our understanding of cosmic structure. Their existence suggests that we are still in the early chapters of cosmic discovery. That even now, with all we know, there are still secrets hiding in plain sight. And the telescope, quiet and faithful, continues to find them, bit by bit, light by light. Eventually, the universe itself will grow quiet. Galaxies will drift farther apart, pulled by the expansion of space. Star formation will slow as gas becomes scarce. The brightest lights will fade. Even black holes over unimaginable timescales will evaporate. This distant future, known as the heat death of the universe, is not something we will see, but it is something the universe moves toward slowly, gently. And in that future silence, all the voices of galaxies will have spoken. But until then, we listen. Until then, the telescope stands like a poet in the dark, capturing the last notes of a symphony still unfolding. There is comfort in knowing that our place in this story is not at its end, but in its middle. We are watchers, readers, listeners. The photons that enter our telescopes are not just data, they are greetings from across time, carried faithfully across emptiness to meet us. We are not intruders in this cosmic dance. We are dancers ourselves, made of the same dust, moved by the same forces, pulled by the same longing to understand. The galaxies may be ancient, but they still speak to us. And we, with our mirrors and sensors and human hearts, still answer with awe. So next time you see a telescope, whether large or small, in a dome or in a book, remember that it is not just a machine. It is a listener, a translator, a bridge between here and there, now and then. It listens to the silent voices of ancient galaxies and brings their stories home. And in those stories we find ourselves, not separate from the stars but of them, not lost in the cosmos but embraced by it. Every galaxy is a memory, a lesson, a gift. And every photon caught by glass and mirror is a thread, weaving us into the vast, quiet, eternal fabric of everything. There is a stillness to the night sky that feels like the surface of a deep sea, calm above, endless below. And just as sailors once peered over the rail of a ship to glimpse the unknown depths, so do we lean toward the sky, searching its darkness with instruments of glass and patience. Telescopes are the windows through which we look, not into water but into time, distance, and silence. These windows, shaped with care, are not mere tools, they are invitations. They do not force the universe to speak, but instead make space for it to whisper. Through their polished lenses and curved mirrors, light drifts gently into focus, bringing with it quiet stories from the other side of the cosmos. And as we gaze through these glass windows, we discover not only the stars, but the depths of our own longing to understand what lies beyond. The first telescopes were made from simple lenses, clear, round pieces of glass that bent light gently as it passed through. These lenses gathered starlight the way a still pond gathers falling leaves, softly, patiently, without rush. Galileo's telescope, a modest instrument no longer than a walking stick, revealed craters on the moon and moons around Jupiter. Through that little window, the universe became layered and complex. Suddenly, Earth was no longer the center of the cosmos, but a part of something vast and dynamic. The telescope did not shout this truth. It simply showed it quietly with clarity and grace. And from that moment, we have never stopped looking. Lenses work by refraction. As light enters the glass at an angle, it bends toward the center, changing direction in a controlled way. A curved lens brings parallel rays to a single point, called the focus, where an image begins to take form. In early telescopes, this was done with long tubes and carefully shaped glass, each element chosen for its purity, its smoothness, its ability to guide light without scattering it. But glass is not perfect. It can split light into colors, creating halos or rainbows around bright objects. This chromatic aberration was a challenge for centuries, until the invention of compound lenses, paired pieces of different glass types that corrected each other's distortions. The result was clearer, truer images. And through these improved lenses, the universe sharpened its outlines, allowing us to see farther, finer, deeper. With the rise of reflectors, lenses found new companions, mirrors that bent light by reflection instead of refraction. Yet lenses never disappeared. They remained vital parts of the optical path, focusing and refining the image after it had bounced from mirror to mirror. In many modern telescopes, lenses and mirrors work together in harmony, each correcting the other's limitations, each bringing the image closer to perfection. And still, the light must pass through air, through glass, through filters, layers upon layers, before it reaches the eye or the sensor. Each layer must be crafted with exquisite care, not only to transmit light efficiently but to preserve its purity. A single scratch, a slight fog, can scatter photons and dull the universe's message. So we keep these windows clean, cool, still. We tend to them like gardeners tending the glass walls of a greenhouse, where something delicate and precious is growing on the other side. In space telescopes, where no air distorts the view, glass becomes even more critical. It must withstand launch, vibration, vacuum, and the cold of near-absolute zero. It must remain transparent, unclouded for years or decades. Special coatings are applied, thin films of metal or oxide, layered with precision atoms thick, to reduce reflections, enhance certain wavelengths, and protect the surface from radiation. These coatings are invisible to the eye, but they shape what the telescope can see. A lens coated for ultraviolet light will reveal hot, young stars, One designed for infrared will show us the warmth of dust clouds and exoplanets. In this way, the glass becomes a filter of truth, a way of choosing which part of the universe to listen to more closely. The path light takes through a telescope is long, even in a small instrument. It travels from a distant star or galaxy, through the atmosphere if we are earthbound, through the primary lens or mirror, through correctors, flatteners, and eyepieces or detectors. At each step, the shape and direction of the light is adjusted, shaped not by chance but by design. And though the glass is silent, it speaks through its work. A planet becomes a sphere instead of a blur. A star splits into a binary pair. A nebula shows filaments and swirls instead of haze. The universe becomes articulate, expressive. And all of it, every detail, every color, comes through these carefully crafted windows on the sky. Even the shape of the lens matters. A simple convex curve brings light to a point, but complex shapes like a sphere's reduce distortion and improve sharpness across the field of view. Grinding and polishing such lenses is a delicate task, done in clean rooms with fine abrasives and constant testing. The surface must be perfect not only in shape, but in texture, smooth to the nanometer, free of pits or bubbles. And when the lens is finished, it must be mounted without stress, kept stable through changes in temperature and humidity. Each piece of glass becomes part of a larger system, a symphony of optics, structure, and control, and the music it plays is light. Astronomers do not just build telescopes. They design them for specific tasks, some for wide fields, to scan the sky for movement or variation, others for deep fields, to stare at a single patch for days and reveal the faintest galaxies. Some use adaptive optics, where a flexible lens or mirror changes shape to correct for atmospheric turbulence. Others use guide stars, lasers projected into the sky, to measure distortion and compensate in real time. In all of these, glass remains at the center. Glass that sees, glass that bends, glass that listens. It is not the size of the telescope alone that matters, it is the quality of the window through which we view the cosmos. A perfect lens in a modest scope can reveal more than a flawed one in a giant, because clarity is not just a matter of size, it is a matter of truth. And then there are spectrographs, devices that take light from a telescope and break it into its component colors. These too rely on glass, prisms, diffraction gratings, lenses to focus and spread the spectrum. The spectrum becomes a barcode, a signature of the object. It tells us temperature, composition, motion, even magnetic fields. It tells us if a star is spinning, if a galaxy is growing, if a planet has water in its air. This information, so rich, so precise, begins with glass. Without it, light would remain blended, its secrets hidden in white glow. With it, light unfolds, revealing layer upon layer of meaning. To look through a telescope is to place your eye at the end of a long journey. You are the final stop for light that began in the heart of a star, crossed millions of light years, entered a lens crafted by human hands and came to rest in your vision. That moment, brief, silent, is a union of nature and mind, of cosmos and curiosity. The glass does not speak. It does not command. It simply offers what it receives as purely and clearly as possible, and in that offering we are invited to wonder, to imagine, to listen to the sky as if it were a sea full of unknown depths. Let's travel deeper now, following the light that passes through these quiet windows, deeper into the dark ocean of space. Through the lens of the telescope, each star becomes more than a pinprick. It becomes a sphere, a system, a history unfolding slowly in the sky. And beyond those stars lie galaxies, entire collections of light, motion, dust, and time, turning slowly across the ages. The telescope's glass lets us enter these distant places without ever leaving the Earth. It allows us to study things that no spacecraft could ever reach. It bridges the distance not by touching but by seeing. And through this act of seeing, we become participants in the universe's long, slow unfolding. Not outsiders peeking in, but listeners, readers, translators of the silent light that washes over us every night. When we look at the planets of our own solar system, the lenses bring their colors and textures into stunning focus. The rust-colored deserts of Mars, the swirling storms of Jupiter, the ringed majesty of Saturn, all become real, immediate, familiar. Through the telescope's glass, we no longer see distant lights but living worlds. Some carry clouds, wind, seasons. Others hold secrets beneath icy crusts. Telescopes show us volcanoes on moons, storms on gas giants, and shadows of rings sweeping across planetary faces. These are not snapshots frozen in time, but living scenes changing with each night's return. And in the subtle shifts, the movement of a shadow, the widening of a storm, we witness the breathing rhythm of the solar system. Each orbit, each spin, each axis tilt becomes visible in its own language of light and shadow. Even comets and asteroids become alive under the lens. A distant speck transforms into a tumbling body with shape, texture, and a tale of ancient origin. Some carry water, some metals, some dust older than our planet. Their trajectories tell us about the past, their surfaces tell us what space has done to them. And as they pass close to Earth, their reflections in the telescope's lens are like soft footsteps across the sky, brief, silent, and deeply meaningful. The lens gives us not only warning but insight. We learn about impact, formation, and preservation. We learn that even the smallest fragments of the cosmos have something to teach. Glass also lets us look inward, back toward Earth. Satellite telescopes gaze down through carefully aligned lenses and mirrors, watching the weather shift, the oceans rise, the forests breathe. These instruments, orbiting high above, use glass not to explore what is distant but to understand what is near. They see wildfires bloom and fade. They track hurricanes swirling over oceans. They study the patterns of crops, the colors of coral reefs, the changing shapes of glaciers. The same principles that let us see distant stars help us see our home with clarity, compassion, and care. These windows show us the fragility of Earth, the interconnectedness of air and land and water. And in doing so, they remind us that exploration is not always about going farther. It is also about looking closer, more gently, more truthfully. Telescopes have also grown more sensitive to light we cannot see. Ultraviolet light, which reveals hot, young stars and violent outbursts. Infrared light, which shows us the warmth of dust and the slow formation of planets. X-rays, which come from black holes and supernovae. Each of these wavelengths needs its own kind of glass, its own coatings, its own careful tuning, and each reveals a different side of the same sky. The lens becomes not just a tool for seeing, but a doorway into invisible realms. Through it, we learn that the universe is layered, rich, and full of whispers in every color we can and cannot name. We come to understand that light is not one thing, but many, and that only by listening to all of them do we hear the true harmony of the cosmos. Even the moon, our closest neighbor, becomes a different world when seen through glass. Its craters deepen, its plains widen, its shadows lengthen with each passing hour. We watch it rise, phase by phase, cycle by cycle, until we know its rhythms like a familiar song. Through the lens, we see not a flat disk, but a three-dimensional place with mountains, valleys, and ancient scars. We trace the paths of past missions, spot the gleam of equipment left behind, and imagine future footsteps. The moon becomes more than a symbol. It becomes a destination, a companion, a part of our story. All of this, seen not with the naked eye, but through the quiet magnification of a glass window aimed skyward. Even the most powerful telescopes, those built in deserts, on mountain tops, or launched into orbit, begin with human hands shaping glass. In laboratories and workshops, artisans and engineers grind and polish until the surface becomes invisible, until it no longer distorts or resists, but welcomes the passing light. This craft is an act of deep patience. It can take months or years to shape a lens or mirror to the precision required. And yet, once installed, that piece of glass becomes a keyhole into the universe. It becomes a tool that outlives its maker, a vessel for curiosity, a conduit for wonder. It is as though the lens becomes not just transparent but timeless, allowing the light of ancient stars to pass through our moment, unharmed, undimmed. And still, the experience of looking through a telescope remains deeply personal. Whether a child in a backyard or an astronomer in a remote observatory, the moment when an image comes into focus is always quiet. There is no fanfare, no shout. Just a breath held, a hush felt, a stillness entered. The lens offers what it sees, and we respond not with noise but with wonder. We may speak later of distances, of magnitudes, of coordinates, but in that first moment there is only awe. And that awe, once stirred, does not fade. It stays with us. It changes how we walk under the stars. It changes how we think of home. Glass in its essence is a medium. It neither creates nor alters the light. It simply lets it pass, shaped with care, with calm, with precision. It is humble. It does not seek attention, but through it the sky becomes knowable. The darkness becomes familiar, and the cold vastness of space becomes a place we can reach with our hearts, our minds, and our eyes. In this way, the telescope's glass is not just a scientific achievement. It is a gesture, a quiet offering of clarity in a universe full of mystery. Now let us return once more to the stillness of the observatory, where the telescope rests like a sleeping guardian beneath its dome. The glass lens, now cool and quiet, has spent the night gathering light from stars and planets, galaxies and comets, bending their messages into form and meaning. In the early morning hush, before the sun returns to wash the sky with light, the telescope is closed, its mirror covered, its glass shielded, its stories recorded. And yet what it has captured lingers, not just in images or data, but in the hearts of those who look. These windows on the dark ocean are not just portals for light, they are portals for wonder, memory, and timeless connection. The stories told through glass are never exactly the same. One night the sky is clear and crisp, revealing fine detail in the Andromeda galaxy. Another night, high-altitude winds create shimmer and blur, softening the edges of Saturn's rings. But even when imperfect, the glass delivers something essential. It allows us to witness change. A nova that appeared suddenly, glowing in a constellation where no star had shone before. A comet's tail lengthening as it approaches the sun. The slow, subtle motion of a distant star revealing an unseen exoplanet tugging gently at its side. These shifts may be small, but through glass, they become monumental. They remind us that even in the stillest corners of the sky, nothing remains fixed. Everything breathes. In schools and science centers, telescopes with simple lenses invite young eyes to explore the heavens for the first time. A child sees the moon and gasps. It is no longer a flat circle in the sky, but a textured sphere filled with mystery. Through this encounter, something changes. The universe becomes real, tangible, close, and with that closeness comes a sense of responsibility. We begin to care for the world not only because it is ours, but because it is part of something larger, something we can now see. These early moments of looking through glass are not small. They are seeds. Seeds of curiosity, of courage, of dreams that may one day send someone to build the next great window into the cosmos. Professionals, too, return to the lens night after night not for routine but for renewal. Each observation is a question. What has changed? What remains? What new signal might emerge from the noise? They study not just the spectacular but the subtle, the flicker of a variable star, the dimming of a far-off sun, the curve of a distant galaxy's arms. And in each observation there is trust. Trust in the lens to remain true. Trust in the mirror to hold its shape. Trust in the data to speak, gently and slowly, the truth of the sky. In this trust, the telescope becomes more than a tool, it becomes a partner, a companion in a long and quiet search for understanding. Even as technology evolves, as digital sensors replace film and algorithms enhance detail, the role of glass remains unchanged. It is the first contact, the initial embrace between starlight and seeing. Without it, there is only darkness. With it, there is possibility. No software can replicate the way a photon bends through a lens, the way focus sharpens to a single point, the way a real image forms. The light that enters a telescope is the same light that left a star 100, 1,000, 1,000,000,000 years ago. That light has traveled straight, uninterrupted until now, when it meets a curve of glass shaped by human hands. In that meeting, the story becomes ours. In remote deserts, under skies so dark they shimmer like ink soaked in silver, telescopes are lined up along ridges and valleys. Their glass eyes watch the sky all night, capturing the faint breath of ancient galaxies. Here, the air is dry, the winds quiet, the stars countless. Each observatory has its rituals, calibrations at twilight, alignments with reference stars, dark frames to measure background noise. And through each lens flows a river of photons, older than any human monument, telling of explosions, births, collisions, and flows of gas that shaped the cosmos long before Earth took shape. To witness such light is to be reminded of time not in years or centuries, but in eons and epochs. It is to feel not small but vast. Sometimes the lens reveals something unexpected, a transiting exoplanet, a supernova in a familiar galaxy, a sudden outburst from a distant quasar. These surprises, caught in real time, are gifts. They remind us that the universe is not static, it is alive with change, and it is watching us in its own way as we watch it. The light that reaches us now is old, yes, but it is also immediate. It was meant for this moment, this night, this lens, this eye. And we, by looking, complete the journey. We close the loop. We become part of the story the light has been trying to tell. Glass also brings balance. It reminds us that not all exploration is loud or fast. Some of it is slow, patient, and delicate. It reminds us that clarity takes time, that focus must be earned, that truth, when it arrives, often does so in silence. A faint glow at the edge of a field, a sharp ring where before there was only blur, a pattern that emerges only after many nights of watching. These are the kinds of discoveries made through lenses. These are the revelations that reward the steady gaze. And at the end of the night, when the dome closes and the telescope rests, the images remain, stored in memory cards, scribbled in logbooks, imprinted in hearts. The sky will change again tomorrow. The clouds may come. The moon may rise, but the glass will wait. It will wait to gather again, to focus again, to reveal again. Like a window left ajar, it lets in just enough of the infinite to keep us wondering. So let us cherish these windows. Let us keep them clean, aligned, protected. Let us build new ones better and braver. Let us teach others how to look through them. Because in the end, it is not the machine that matters most. It is the act of seeing. And what we see through glass are not just stars and planets, but reflections of our own desire to know, to feel, to belong. The telescope's glass window, polished and still, is both lens and mirror. It shows us the sky and it shows us ourselves, part of the same vast ocean, watching and being watched, forever in motion, forever aglow. Long before we understood what it was, light guided us. It danced across the surfaces of rivers, warmed our faces at dawn, scattered into colors after rain. It crept through forest leaves and spilled into quiet rooms, always present, always leading the way. And in the night, when the world grew still and the sky opened wide, it painted itself into the stars, points of brightness flung across a deep and endless canvas. Even then, before telescopes, before science, we followed it. We built our calendars from the motions of stars, our myths from constellations, our paths by the moon's pale trail. Light, without words, became our first teacher. It showed us time. It gave us direction. And in its silent presence, we began to wonder, what lies beyond the glow? When telescopes entered the story, the light we followed became more than distant dots. It became information, measurable, knowable, full of hidden meaning. A simple lens or mirror allowed us to gather more of it, to focus it into sharpness, to separate it into colors. The more light we collected, the more the universe revealed. Galaxies bloomed from haze. Planets emerged from points. Nebulae unfurled like sleeping clouds. But even as our instruments grew more refined, the magic of light never faded. It remained mysterious, even as we learned to measure its speed, to split its wavelengths, to trace its origins. Because every beam of light is a message from a moment long gone, a journey across time, through space, into our waiting eyes. Light, we came to learn, is not a single thing. It is both wave and particle. It moves in straight lines but can bend when it meets gravity. It carries energy and momentum. It can be reflected, refracted, absorbed, or scattered. It is the reason we see color, the reason we feel warmth, the reason photosynthesis gives us life. And beyond the visible lies more: infrared, ultraviolet, X-rays, gamma rays, radio waves, all part of the electromagnetic spectrum. Each one a flavor of light, a different voice in the same cosmic choir, and each one carries its own story, waiting to be heard by the right instrument. Telescopes, tuned to these different frequencies, allow us to hear the full song. Visible light, the kind we see with our eyes, tells us of stars. It shows their surface temperatures, their colors, their age. Hot stars shine blue and white. Cooler ones glow orange and red. By studying their spectra, the rainbow split by prisms and gratings, we discover what elements burn within them: hydrogen, helium, iron, carbon. These spectral lines are like fingerprints, unique and reliable. They let us understand the physics inside a star, even from light years away. And they also tell us how fast a star is moving, whether it drifts toward us or away. This Doppler effect, this redshift and blueshift, lets us measure motion not through touch, but through light's quiet drift. Infrared light, just beyond red, reveals what lies behind the dust. Many parts of the universe are veiled, shrouded in clouds of gas and debris that block visible light. But infrared slips through, warm and soft, carrying images of star nurseries, of forming planets, of ancient galaxies whose light has been stretched by the universe's expansion. Telescopes like the James Webb Space Telescope are built to listen to this kind of light. They peer into the places where stars are born, where galaxies first assembled, where the echoes of the earliest moments still linger. And through this gentle warmth, we see not just what is, but what was becoming. Ultraviolet light shows us heat and youth. Young stars shine brightly in UV, their high-energy radiation ionizing nearby gas, creating glowing regions of star formation. This light is blocked by Earth's atmosphere, so we must go to space to see it. There, above the clouds, telescopes like the Hubble catch UV light from faraway galaxies, from quasars, from the outer atmospheres of stars. And in doing so, they reveal the places where creation burns brightest, where energy flares high, where time moves quickly and change is constant. This is light in its most excited form, and it guides us toward the places of birth and transformation. X-rays and gamma rays speak of violence, supernovae, black holes, neutron stars. These forms of light are not seen with eyes, but detected with specialized sensors. They come from matter accelerated to near light speed, from particles colliding in magnetic storms, from the final moments of massive stars. To capture them, we build telescopes with unique mirrors and detectors, often placed in orbit to avoid Earth's absorbing atmosphere. And through these rays, we see the scars of the universe, its eruptions, its collapses, its wild extremes. Yet even these violent origins are rich with meaning, for they are part of the same great story, and light remains our guide, even in its most chaotic form. Radio waves are the longest, softest voices. They drift from spinning pulsars, from cold hydrogen clouds, from the cosmic microwave background itself, the faint afterglow of the Big Bang. Radio telescopes are vast dishes, often grouped in arrays, working together to trace these quiet whispers. They map the large-scale structure of the universe, show us how galaxies cluster, and reveal the slow rhythms of rotating stars. In radio light, we find peace, distance, and echoes too soft for other instruments to catch. And in those echoes, we find the shape of space itself, the web of gravity, the drift of time, the memory of beginnings. All of these forms of light, all of these frequencies, are just ways the universe communicates. The telescope is the translator, the astronomer is the listener, and light, silent, patient, eternal, is the voice. It crosses space without a sound, without losing strength, without needing rest. It travels for billions of years, unchanging, carrying the precise imprint of its origin. And when it arrives, after all that time, it asks nothing. It simply offers its story. And if we are ready, if we are watching, if we have shaped the glass and tuned the mirrors and placed our eyes just right, then we will hear it. And in hearing, we will know. To follow light is to follow truth. not the kind found in argument or opinion, but the quiet, natural truth of being. The truth that stars are born and die, that galaxies drift and spin, that time expands and space bends, that what we see is shaped by how we look and yet also by how light has traveled. We follow it not to control but to understand, to be in harmony with something larger than ourselves, something ancient, something endlessly unfolding. Let's journey onward, deeper into the soft trail of light that leads us through the cosmos. When we follow light, we are not simply observing brightness, we are reading time. Each beam that touches our telescopes began its journey long ago, from a place far away, carrying with it not just color and energy, but age and memory. To see a star shining in the night is to see it as it once was, perhaps thousands or even millions of years ago. A galaxy, glowing faintly at the edge of visibility, might be showing us its infant stage, even though today, at this very moment, it may be vastly changed or gone. This is the gentle paradox of starlight. It illuminates the present by carrying us into the past. Through the patient eye of the telescope, time opens like a scroll, unrolling its stories in wavelengths too fine for our skin to feel, but perfect for our hearts to understand. Light also teaches us about movement. Through redshift and blueshift, we learn that the universe is expanding, that galaxies are moving away from one another not because they are being pushed, but because the space between them is stretching. This quiet revelation, first discovered in the early 20th century, changed everything. It told us that the universe had a beginning, that it is not static but dynamic, that it grows, ages, evolves, and through light we can measure this expansion. The farther a galaxy lies, the more its light is redshifted, lengthened like a stretched ribbon. From this simple shift, astronomers calculate distances, estimate ages, and map the flow of cosmic time. All of it whispered in the soft language of traveling photons. Through light, we've also come to understand that the universe has structure. Galaxies are not scattered randomly, but form clusters and filaments, shaped by gravity into vast cosmic webs. These patterns are seen in the way light bends and dims, in the clustering of galaxies, in the gentle lensing effects caused by invisible dark matter. When light passes near a massive object, such as a galaxy or cluster, gravity bends its path. This phenomenon, gravitational lensing, creates arcs and halos, magnifying distant objects and revealing what lies behind them. In these distortions, we do not see error, we see elegance. The universe bends its light not to confuse, but to show more, to offer deeper layers. And through these curved paths, we learn about mass we cannot see, about structures that tug at the fabric of space itself. Some of the most delicate work in astronomy comes not from looking at bright objects, but from studying the faintest background, the cosmic microwave background radiation, or CMB. This soft glow, discovered in the 1960s, is the oldest light we can observe. It comes not from stars, but from a time before stars existed, when the universe was just 380,000 years old. Back then, light finally escaped the dense fog of the early cosmos, traveling freely through space for the first time. That light still surrounds us, stretched into microwaves by the expansion of space. Sensitive telescopes, tuned to this faint signal, map tiny variations in temperature and density, variations that became galaxies, stars, planets, and eventually us. The CMB is not a message in words, but a fingerprint of creation itself, carried quietly by light through the vast corridors of time. Light also reveals change. Variable stars pulse and dim with rhythmic certainty, like heartbeats across the night. These stars allow us to measure distances, to calculate the scale of space. Some stars flicker because of internal processes, others dim because of eclipses or dust. And by tracking these patterns, astronomers can build ladders of distance, measuring the universe step by step. This is the magic of Cepheid variables, of supernovae, of transiting exoplanets. Each change in light is a whisper from afar, a moment captured in brightness and shadow. And through careful listening, through precise instruments and patient nights, we turn these changes into understanding. Light also helps us map the lives of stars. From birth in dense gas clouds to adulthood on the main sequence to death as white dwarfs, neutron stars, or black holes. Each phase has a signature in light. Young stars shine blue and fast. Middle-aged stars like our sun glow steadily in yellow. Old stars swell into red giants, then fade or explode, depending on their mass. And all the while, they shed light into space, enriching it with the elements they forged in their cores. Every atom of carbon in our bodies, every bit of iron in our blood, was once created in the heart of a star and carried outward by light. The telescope does not just show us stars, it shows us ourselves, carried through space on beams of light that began before we were born. Even on Earth, light plays guide. It bounces off our atmosphere, filters through clouds, paints the sky blue by day and red at sunset. It travels through fiber optic cables, sending data at the speed of near-instant thought. It feeds plants, warms oceans, defines rhythms in the lives of animals and people. Light sets our clocks and regulates our sleep. And just as we depend on it to live, we also use it to explore. Lasers measure distances with precision. Spectroscopes study minerals and molecules. Light is the quiet partner in every scientific discovery, the unseen bridge between what is there and what we can know. And as we send our own light outward, radio transmissions, signals, pulses of data, we join the conversation. Somewhere drifting through space are echoes of our voices, our music, our questions. We have sent golden records aboard spacecraft, beams of light through laser communication arrays, and faint emissions from television and radio broadcasts. These signals, faint and scattered though they may be, are evidence of our desire to connect. We are not only receivers of light, we are senders. And in this two-way flow, we become part of the same tradition the stars began: to shine, to reveal, to guide. So light remains our teacher. It is not loud. It does not shout. But it is always there, showing us what was, what is, and what could be. Through telescopes, through lenses and mirrors, through the filters and sensors that make up our observatories, we collect its messages, translate them into images and numbers, into stories and truths. And with each one, we are reminded that we are part of something grand and luminous. We are creatures of light, shaped by it, seeking it, sending it onward. Now let us follow the light to where it gently fades, where its journey slows not from exhaustion but from distance. Imagine a single photon leaving the surface of a star, moving at the fastest speed known, unbending in its path through the velvet dark. It does not age. It does not pause. It simply travels through gravity wells, past drifting dust between galaxies, until after millions or billions of years it touches a mirror, a lens, a sensor, or your eye. In that moment, its long journey ends. And in its arrival, we find meaning. That one photon, that sliver of radiance, tells us something no book or map could ever offer. It carries the shape of the universe. It holds the breath of a star long gone. It speaks softly yet wholly of how things once were. And when we gather many such photons, streaming from quasars, bouncing off planets, radiating from dust, we gather not only information. We gather echoes. We gather memory. And in this memory lies the story of light's partnership with life. Long before telescopes, long before lenses or theories, organisms began reacting to light. Algae danced in water, tracking the sun. Flowers bloomed at dawn. Eyes evolved in stages, light-sensitive cells, pits for direction, lenses for focus, color receptors for detail. Light wasn't just illumination, it was rhythm, structure, compass. Plants bent toward it. Migrations followed it. Circadian rhythms pulsed with it. Even now, our sleep, our moods, our health, all tuned to its slow daily climb across the sky. The universe didn't just offer light, it offered a pulse, a harmony, and we joined in instinctively. The same photons that carry the age of a galaxy also stir chlorophyll and gently regulate a heartbeat. Light bridges scale, uniting the cosmic and the cellular. And so it was natural, inevitable perhaps, that we would come to worship light, not with temples alone, but with questions, with inventions, with the building of instruments meant to capture it more clearly. The telescope was born of that longing. It began small, glass and wood, a curve shaped by hand. And yet it let in more light. It brought clarity to the once distant. Over centuries, it grew in size and complexity. Space-based observatories were launched. Mirrors grew to the size of rooms. Detectors became sensitive to the faintest pulse. With each new advance, we welcomed more light into our understanding. And with each new image, a nebula curled in stardust, a galaxy spiral opened wide, we saw not just the object but the way light described it. Every photo, every spectral line, is a love letter written by light and patiently interpreted by our minds. Some light reaches us unchanged. Some is absorbed or scattered, reshaped by gas and dust. Sometimes it bends, curved by gravity's pull around massive bodies like black holes or galaxy clusters. In these distortions, we see space itself behaving like a lens, enlarging distant objects, echoing Einstein's predictions. Light doesn't resist this path, it follows it faithfully, bending where space bends, slowing where time slows. And this obedience to the shape of the universe becomes a gift. It lets us see farther. It lets us glimpse galaxies otherwise too faint. It teaches us that space is not an empty stage, but an actor in the story, curving, flowing, guiding the script. Light also tells us what might be missing. When it bends more than expected, we learn of dark matter, mass we cannot see but can measure through its effects. When galaxies accelerate away from each other faster than predicted, we infer dark energy, a force still not understood but profoundly real. Light, by what it reveals and what it fails to show, is honest. It does not lie. It merely reflects the conditions from which it came. And by paying attention not just to brightness, but to pattern, to shift, to echo, we come closer to understanding the shape of the cosmos and the strange forces that shape it. But not all light is ancient. Some is young. It is born now in fusion reactors, in artificial suns, in lasers guiding spacecraft and surgeons. We have learned to create and control light, to use it as a tool for healing, for communicating, for exploring. Fiber optics pulse with it. Telescopes are calibrated with it. Communication with distant probes relies on it. Light, once distant and untouchable, has become something we shape, something we work with, yet always something we respect. Because we know where it came from. We know the deep well from which it rose. And as we look ahead, we imagine telescopes not just passively receiving light, but actively seeking it in new ways. Arrays that use the entire Earth as a lens. Telescopes positioned at lunar poles. Instruments that can detect the faint ripples of the first stars. We dream of collecting light from the first atoms as they cooled, from the surface of rogue planets, from biosignatures floating in exoplanet atmospheres. Each advancement brings us closer not just to discovery, but to clarity. To hearing the universe more clearly, more honestly, more wholly. And through it all, light remains the language in which these stories are told. Eventually, all light will fade, stars will die, galaxies will grow cold, even black holes will evaporate. The universe may slip into darkness, a long, slow dusk with no more light to guide us, but that time lies far beyond us. And until then, light continues to shine. It reflects off ice and stone. It pierces gas and glass. It carries messages written by stars, rewritten by gravity, read by mirrors. And in this endless flow, we find peace. We find presence. We find our own small brightness, brief perhaps, but not lost. Because each time we follow the light, we step into a legacy older than Earth, broader than thought. And so we continue to build instruments that honor this gift. We polish lenses. We shape mirrors. We lift domes into place. We align detectors, adjust mountings, refine codes, not just for science, but for listening, for bearing witness, for greeting the light that comes. When we gaze into the eye of a telescope, we are not escaping the world. We are joining it, joining the dance of particles and waves, of motion and silence, of time and presence. And in that moment, light is no longer distant. It is here, it is now, it is us. Let the light guide you not only through the sky but through life. Let it remind you to be patient, to notice, to receive. Let it teach you that even in darkness something travels, something endures. And when it arrives at a mirror, a lens, a heart, let it rest in you. Let it speak. And let it remind you that you are part of a universe that glows. There is a quiet that arrives when the sky grows dark, deeper than silence, broader than stillness. It settles not just over the land, but inside the heart, like a tide receding into itself. Beneath the stars, the noise of the day fades and the sky stretches open, vast and eternal. It is here, in this soft breath of night, that dreams begin to drift. Not the dreams of sleep, but the waking kind, the ones stirred by the hush of the cosmos and the soft shimmer of starlight. And when we look upward through a telescope, through lenses that bend and mirrors that guide, we are not just observing, we are dreaming. Dreaming with eyes open, minds alert, hearts still. The stars do not demand attention, but they offer it freely. They shine because they do. And we, gazing from a small world, imagine what it means to be part of something so wide, so wordless, so gently endless. From the beginning, we've looked up to find stories. Before telescopes, the sky was our canvas. We saw bears and hunters, swans and serpents. We stitched myths from the light, anchoring memory in constellations. And though modern astronomy has replaced legends with distances and data, the wonder remains. Because when we turn a telescope toward Orion or Lyra or Andromeda, we still feel that familiar stirring, a sense that the sky is not just above us but with us, that we are not alone in the dark. The telescope does not erase our stories, it deepens them. It replaces outlines with galaxies, replaces fables with facts that are no less magical. For who would not be amazed to learn that the stars of the Big Dipper move together through space, born of the same cloud, traveling side by side for hundreds of millions of years? Through the lens, we learn to see differently. The sky is no longer a dome but a field of depth. Stars are not just dots, they are distances. Some closer, some farther, all moving through the currents of the galaxy. The Milky Way itself, once a hazy band across the sky, becomes a spiral of stars, dust, and dark matter with us nestled inside one of its arms. And beyond our galaxy lie others, trillions of them, each with its own stars, its own planets, its own dreams. When we look through a telescope, we are not just seeing objects. We are glimpsing the vastness of place, the layering of time. We are seeing how far we can see and how much more remains. The act of observing the sky is also an act of remembering. Every photon we collect began its journey long ago. The light from a star may have started when humans were learning to plant crops, when ice still covered much of the earth, when continents were drifting into their modern forms. To look at that star now is to touch a moment we never lived but are nonetheless connected to. Time, through the telescope, becomes pliable. The present stretches backward, threading us to the ancient. In a quiet observatory, in a backyard with a simple scope, we become time travelers, not moving through time, but letting time come to us in waves of light. There is also something deeply peaceful about watching the sky. The stars do not hurry, the planets do not rush. Everything moves according to rhythms older than civilization. Saturn will take 30 years to orbit the Sun. Halley's Comet returns every 76. The moon rises and sets with patient grace, pulling tides and shaping nights. To tune into these cycles is to tune out of urgency. The telescope becomes a balm, a reminder that not all motion is frantic. Some of it is slow and steady, unfolding in a language we forget to speak. It teaches us to wait, to observe, to trust that beauty reveals itself not all at once but over time. And in this waiting, something else happens. The mind quiets, the breath slows. We begin to notice more, not just in the sky, but in ourselves. We see how our thoughts drift like clouds, how our hopes rise like stars, how our fears dim in the vastness of perspective. To dream under infinite skies is to feel the boundaries of self soften. We are no longer contained by walls or roles or noise. We become part of the night, part of the gentle unfolding of the universe. And in that vast belonging, we find a rare kind of peace. Not the peace of answers, but the peace of wonder. The peace of not needing to know everything, only needing to look. Even through the simplest telescope, the sky comes alive. The craters of the moon deepen into shadow and shape. Jupiter's moons swing slowly around their planet, changing position night by night. Double stars reveal their dance, two suns locked in embrace. The rings of Saturn, delicate and precise, hover like a dream. Each object, seen clearly for the first time, feels like a secret shared, not because it was hidden but because we were finally ready to see. The telescope doesn't invent these wonders, it introduces us to them. And in doing so, it reawakens a childlike joy that lies waiting in all of us. In dark sky places, where city lights do intrude, the sky opens wider still. The Milky Way stretches overhead in a glowing arc. Meteors streak across the night in brief flashes. Satellites glide silently by. And under this sky, telescope or not, we feel something ancestral, a memory not just of looking but of belonging, of knowing that the stars are not decorations but companions, that the same sky has watched over every life before us and will watch over every life to come. The stars, distant though they are, offer continuity, and the telescope, by bringing them nearer, reminds us of our place in the unfolding story. Dreaming under infinite skies is not about escape. It is about return. Return to curiosity, return to quiet, return to the questions that rise when we slow down enough to listen. Who are we? Where do we come from? What else might be out there? The telescope does not answer these questions directly, but it gives us the courage to keep asking. And in the asking and the looking and the long nights of gentle watching, we find what answers we need, not as conclusions but as feelings, as wonder, as calm, as belonging. And so we continue to look up, to point our glass eyes skyward, to wait and to dream, because the sky never stops offering, and we, in our infinite longing, never stop receiving. Let us now follow the dream a little deeper, where the sky not only watches us, but begins to speak back, softly, slowly, through patterns too subtle to catch without stillness. Telescopes teach us that the universe is not random. Stars return to their places. Planets trace familiar paths. Constellations shift, but gently, across the centuries. Even the drifting galaxies follow threads of gravity woven into the shape of space. These motions, invisible to the hurried eye, become visible when we commit to looking. Through glass and silence, through patience and alignment, the night reveals its rhythms. And as we learn to follow them, we begin to remember that dreaming is not a drifting away, it is a drawing in, a closer attention, a deeper gaze. The sky dreams too, and in its dreaming it carries us. Through the telescope, we witness the strange paradox of light, that it moves so quickly, yet what it shows us is always from long ago. A star's flicker may be its farewell. A galaxy's glow may be from a time before our Earth had oceans. In each beam lies memory, and as that memory falls into focus, we are reminded that nothing we see is ever in the present. The telescope teaches us that everything we observe is part of an unfolding past, and yet in this delay we feel more connected, not less. It's as if the universe left us notes along the way, and only now are we learning to read them. One star at a time, one spiral galaxy at a time, one photon, patiently arriving after a billion-year journey, slipping gently into our lens. Dreams have no weight, and yet they shape us. And so does starlight. It presses against us so lightly we cannot feel it, yet over time it changes the way we think, the way we hope, the way we understand our place in the wide and quiet cosmos. Some nights we follow the tracks of asteroids and comets, watching them arc across the solar system with icy tails glowing in reflected sunlight. Other nights we chase the shadow of a planet crossing its star, a dip in brightness so small and yet so telling. From such tiny flickers we infer worlds, strange and varied, rich with potential, some hot and molten, others icy and dark. A few may be Earth-like, circling calmly in their habitable zones, dreaming in their own quiet ways under distant suns. The telescope brings these dreams into the open. It makes the invisible visible. It makes the improbable possible. It reveals the winds of Jupiter's great storm swirling without rest for centuries. It captures the intricate lattice of Saturn's rings, each a ballet of icy fragments held by gravity's music. It shows us the dim glow of Pluto and the distant stretch of the Kuiper belt beyond. It even lets us look backward, through stellar evolution, to glimpse how stars are born in clouds of gas and how they die, shedding their outer layers in glowing shells or collapsing into dense cores that bend time and space. In these views, there is science, yes, but also poetry, because nothing that vast and beautiful enters the heart without stirring something more than fact. In the high altitudes of mountaintop observatories, where the air is thin and the stars are sharp, the night becomes something sacred. Observers speak in low voices. Red lights are used to preserve night vision. Doors are opened slowly, carefully. Everything is done with respect for the equipment, yes, but also for the sky. This reverence is born of experience. For those who look deeply and often know that the sky does not reveal itself to the unready. It opens slowly for those who are quiet, who are patient, who know how to wait for clouds to pass and mirrors to cool and the earth to turn just a little more. Dreaming under infinite skies is not just an act of looking, it is an act of listening. And in that listening, something ancient stirs. We remember the first humans who looked up in wonder, who charted the stars to guide their boats and mark their seasons, who stood in deserts and forests and mountains, reading the sky without telescopes but with eyes full of wonder. That same wonder lives in us still. It returns when we see the rings of Saturn for the first time, not in pictures, but with our own eyes. It awakens when we find the Andromeda galaxy in a backyard telescope and realize we are seeing a galaxy like our own, 2.5 million light-years away. These are not just observations, they are connections, threads woven between ourselves and the fabric of everything. Sometimes the telescope shows us beauty so perfect it feels imagined. A nebula glowing in pinks and blues, its shape like wings or flames or flowers. A spiral galaxy with arms curving gracefully, wrapped in dust lanes and newborn stars. A globular cluster, hundreds of thousands of stars packed so tightly they sparkle like frost. And even though we know the physics behind it, the temperature, the chemical reactions, the gravitational pulls, none of it diminishes the wonder. The telescope reminds us that knowledge and beauty are not opposites. They are companions. The more we understand, the more awe we feel, because the truth of the universe is that it needs no exaggeration. It is already extraordinary. And as we dream under the stars, our thoughts often drift toward the question, are we alone? The telescope has not yet answered that question, but it has given us context. It has shown us thousands of planets circling other stars. It has revealed molecules in atmospheres, clouds on alien worlds, storms on distant giants. It has opened our minds to the possibility that life, while precious, may not be rare. And even if we find nothing, even if the universe remains quiet and vast, the search itself brings meaning. The act of reaching out, of hopping, of dreaming beyond ourselves, that is a kind of connection, a kind of belonging, and it is no small thing. To gaze upward through a telescope is to place oneself humbly in the flow of time, to let go of the day's noise and enter the long rhythm of stars, to remember that the earth spins, that seasons shift, that light travels, that dreams rise. It is to know in your quietest breath that you are part of the same universe that you are observing, not apart from it, not beneath it, but of it, made of its dust, warmed by its stars, guided by its light. And when you close your eyes after such a night, what you carry is not just data but a feeling, soft, steady, and luminous. As the night leans toward its quietest hour and the stars sit still above the earth, we return once more to our place beneath the sky, not to ask more questions, but to rest in the wonder that questions have brought. The telescope, no longer scanning or adjusting, stands still under the dome or sky, its gaze paused, its mirrors cooling. And we beside it feel a stillness within us, a calm that matches the sky's own breath. Dreaming under infinite skies is not a single moment. It is a practice, a rhythm, a return. Again and again we come to the stars, and again they open, not with drama but with invitation, to look deeper, to feel smaller, to wonder longer. Each time we do, the world inside us shifts ever so slightly. We carry the vastness home in the silence of our thoughts, in the warmth behind our eyes. Even after we pack up the telescope or walk away from the observatory, the light stays with us. It may no longer form rings or galaxies in the lens, but it remains in the mind's eye. The image of Jupiter's bands, the delicate threads of a nebula, the pinpoint clusters of a distant galaxy, they linger like dreams remembered after waking. And perhaps that is what makes stargazing through a telescope so powerful. It allows us to hold onto the invisible, to grasp the unreachable, to bring the infinite into focus, just long enough to feel it before it slips away again. We cannot keep the stars, but we can carry what they mean. And sometimes that meaning is enough to change the shape of a life. For the children who see the moon up close for the first time through a telescope shared at a schoolyard or a park, there is often a moment of stillness, a pause, a gasp, and then the words, "It's real." As if until now the moon had been an idea, a shape, a symbol, but now through the lens it becomes a world, with texture and depth and shadow. And in that transformation something opens in the child, a door perhaps, or a question, or a dream. The telescope is more than glass and gears, it is a key. A way to unlock wonder in those who have not yet learned to expect it. And every night that it is used becomes a night when someone, somewhere, learns that the sky is closer than they thought. This is true not only for the young. For all of us, no matter how much we have studied or how many times we have looked, there is always something new, a comet we didn't expect, a satellite crossing the field of view, a star we hadn't noticed before. The universe is not a fixed picture, it is alive, in motion, unfolding. The telescope, as still as it may seem, is always looking into a living story, and in watching we become part of that life. Our breathing matches the turning of the dome. Our thoughts slow to the pace of distant suns. We begin to measure time not in minutes or hours, but in phases of the moon, in the rising of constellations, in the return of seasonal stars. The connection deepens when we observe not just the spectacular but the subtle, when we track the slow change in brightness of a variable star, when we sketch the movement of a shadow across a crater, when we watch, night after night, the wandering of a planet through the background of stars. These are small changes, barely visible, and yet through attention they grow into something profound. We learn patience. We learn care. We learn that discovery is often the reward for showing up again and again with open eyes. The telescope does not demand brilliance, it asks for presence, and in giving it we are transformed. There is also a quiet solidarity among those who dream beneath the sky. Amateur astronomers, professionals, artists, and wanderers, all finding something different and something shared in the act of looking up. Across cultures, across centuries, people have turned their gaze to the stars. The tools have changed. The theories have grown. But the impulse remains, to look, to learn, to feel. It is a human instinct as ancient as breath to find stories in the dark. And each of us in our own way contributes to that story. A new discovery here, a photograph there, a poem written in moonlight, a moment of awe whispered to a friend. We are all part of the same constellation of seekers. And what we seek is not only out there, it is also within. The telescope, in revealing the vastness of the universe, reflects something about ourselves, our desire to know, our openness to beauty, our capacity for wonder. These are not just scientific traits, they are human ones. And the more we explore the sky, the more we understand that it mirrors our own inner space, full of light and darkness, motion and stillness, mystery and meaning. The telescope, then, becomes not just an instrument for seeing the stars, but a companion in the search for self. Eventually, every night ends. The stars fade into morning. The telescope is covered, stored, made ready for next time, but the dreaming continues. In our thoughts, in our plans, in our conversations, we carry forward the memory of light, of how it bent through our optics and into our eyes. We remember the way Saturn hovered like a jewel, the way a meteor cut a line across the sky, the way a child's voice lit up with recognition. And these memories gather, layer by layer, until they form something lasting, a quiet confidence, a lifelong curiosity, a peace that rises whenever we look up. So let us keep dreaming under infinite skies. Let us build better telescopes. Let us share them freely. Let us teach others not just what to see, but how to see. Let us protect the darkness that makes the stars visible. Let us treasure the silence that gives the sky its voice. And let us never stop wondering, not because we expect an answer, but because the question itself is sacred. In the end, the stars will remain. They will shine through centuries, through change, through all our shifting stories. And the telescope, like a window gently opened, will always be there to welcome their light. We only have to look. And in looking, we remember that we are part of something vast and beautiful and alive. Something that dreams with us, above us, within us.